Hey guys, so this is our stoichiometry crash course. First thing you need to know about stoichiometry is a hydrate versus an anhydrous compound. Remember that hydrates are compounds that are actually with water. So, for instance, you have copper sulfate with 5 dot waters that are within there. So what I would do is to find this molar mass, I would find the molar mass of copper sulfate, and then I would find the molar mass of 5 waters, and then I would just add those two compounds together. For anhydrous compounds, they don't contain water, so you would just see it as a regular copper sulfate right there. Another thing you need to know for stoichiometry is mass percent. Remember that mass percent can also be termed percent composition. The way that we calculate mass percent or percent composition is part divided by whole times 100. So if you have, for instance, that copper sulfate pentahydrate compound, like so, you can figure out the mass percent of water within this whole compound. So your part would be the mass of your water, the whole would be the entire compound, and you would multiply by 100. You also will be asked about some things with mole fraction. The way we do mole fraction is the moles desired divided by your total moles. And make sure you do not change this into a percentage. They like for you to leave it in a decimal. Another part of stoichiometry is doing empirical formula and molecular formula. Remember that empirical formula is the simplest whole number ratios between the elements in a compound. So most of the time they give you mass percents, and what you do with those mass percents is you change that mass percent to grams. After you change that mass percent to grams, you then have to change those grams to moles, and this is moles of each element. After you change those into moles, you then divide by the smallest number of moles. That smallest number of moles will give you whole number ratios. If it does not give you whole number ratios, then what you'll have to do is multiply by 2 or 3 or something to give you those whole numbers. If they don't give you mass percent, sometimes they'll give you a compound where it says that they combust it or it's reacting with oxygen. So let's say you have some compound that has C's and H's in there. So what you're going to do to evaluate what this empirical formula is react it with oxygen. When you react that with oxygen, you get CO2 plus H2O. So what they'll end up doing is giving you some information about the CO2 and some information about the H2O. It's usually in grams. So what you have to do is take this CO2 to find grams of carbon and then moles of carbon by itself. So you work a stitch. So you would say, however many grams of CO2, you would divide by the molar mass of CO2, and that would give you moles. And then you would do a mole to mole ratio, where your mole to mole ratio is 1 CO2 contains 1 carbon. So 1 CO2 contains 1 carbon. So that would give you moles of that compound. This will then give you moles of just carbon, and this will be where you're left at right there. Then if you have water, you would do the same process, divide by molar mass of water, moles, and in this case you have 1 water, so 1 mole of water contains 2 hydrogens. So then that would give you the moles of hydrogens that you would have. After that, you would divide by the smallest number of moles, then that would give you your whole number ratios. So that's how you do empirical formula. For molecular formula, this is the actual whole number ratios between the elements in a compound. The first thing you need to know to be able to do a molecular formula is the actual molar mass. Okay. The actual molar mass, most of the time, you'll have to calculate with the molar mass kitty cat equation. So molar mass equals dirt over P. D stands for density, R stands for your gas constant, which is 0.0821, T is your temperature in Kelvin, and P is your pressure in atmospheres. When you calculate this, this is your actual molar mass. Once you have your actual molar mass, you take actual divided by the empirical formula molar mass. And how I would do that is just add it up like you would from your periodic table. That ratio right here is going to give you some whole number. And what you do is you take the empirical formula. Let's just say, for instance, we found that the empirical formula was C2H4, right? So if this whole number was 2, then we'd have to distribute that 2 through this. So my empirical formula would be C2H4, but my molecular formula would be C4H8. And that's how you work empirical molecular formula. The next thing is limiting reactants and percent yield. Remember that when you are working with limiting reactants, how I know that I'm in the land of limiting reactants is you have information on more than one reactant. Anytime you are given that, whether it's a multiple choice or a free response question, you have to work a limiting reactant problem. And how we do this is our Rice chart. Remember, for the Rice chart, for limiting reactants, you always need to be in moles. When we are working percent yield, then we have theoretical yield, which is the calculated value, actual yield, which is the value acquired via experimentation, and then percent yield, the way we calculate that is actual divided by theoretical times 100, and that's how you get the percent yield.